Bonnie Maldonado is a professor of pediatrics. She's the chief of infectious disease, pediatric infectious disease at Stanford. She's at and also runs Global Child Health and is a WHO consultant. And she's going to talk to us about the what, how, and why of how infectious diseases and how climate impacts infectious diseases and has an impact.
Thank you, everybody. And it's really an honor and a privilege to be here with this group of consumers, activists, experts. And I'm an infectious disease epidemiologist at Stanford, and I focus on child health globally. Michelle and I have worked together many, many years, and I want to make a plug for the fact that we want to talk about positive, what can we do, how can we make a difference? And one of the things that we have seen around the world, I won't have time to talk about this today, is that we have really had remarkable achievements in what we can do if we have political and activist will to make changes. And that is that we have, for the first time ever, we have had less than 5 million children in the world die in a year. So 25 years ago, there were 12 million children who died every year. And now this year, in 2016, the last year for which we have data, that was actually 4.8 million children. The vast majority of the early infections, the early deaths, were infectious diseases, and today that accounts for only 25% of deaths. Now, any death of a child under 5 is a terrible thing, but the fact is that we were able to bring these numbers down because we collectively got together and decided that we can make a difference. So I do think that this sounds like a very scary, big problem, but we can really conquer these issues. So let me talk a little bit about 3 things. First, I want to talk about the interactions between humans, environment, and pathogens or harmful organisms in the environment. Then I want to talk a little bit about the climate-related infectious diseases and some of the impact on children. We don't really know that impact yet, but we can project some of that based on what we know now about current trends. And then finally, as we had talked about, some potential efforts to mitigate some of these climate-mediated changes in infectious disease threats. And we know that infectious diseases hit the headlines because they are immediate things we see today. So you can think about climate change and think about children's development over 10 or 20 years. And it's important to visualize that, but it's hard to remember that on a day-to-day basis, whereas infectious diseases hit the headlines right away. So global emergencies, for example, come in all forms. But this is an interesting slide that came from the World Health Organization, where you see around the world global emergencies that were being addressed immediately in May of this past year. This is the most recent slide. And you can see the color of the country or the region indicates how severe the event was. And you can see the red regions are here. But there are smaller global emergencies around the world. But the other thing that's important is the magnitude of the emergency and the cause of it is shown in the little circles. And the circles, this blue, which is virtually almost every circle, is infectious. So, and then this one here is disasters. So you see that disasters and infections make up a big chunk, and we don't know what kinds of disasters those are, but some of those are going to be environmental disasters, for example, due to climate-related issues. And even this one here, which is not an infection or a disaster, is related to a zoonosis, which is an animal-to-human transmission of disease. So we see that infections are really kind of a signal or sentinel for what might be going on in the environment. When you look, for example, at emerging outbreaks around the world, just in the last 13 years, you can see that we had, I don't know if any of you remember SARS. I teach a class, 2 classes at Stanford to the undergraduates, and they're pretty bright kids, but they are, I mean, to me at my age, they are kids. And none of them, you know, we talk about this class, and over the years I mentioned this and nobody remembers what it is. But we remember how scary severe acute respiratory syndrome was back in 2003. So we saw that. We have Zika virus. I don't know that anybody has not heard of Zika virus, and it's been around forever. We know at least since 1947 it was found in Africa, but for a lot of reasons, which I'll go into in general, we now see it all around the world. Chikungunya, which is another virus related to Zika. It's very similar, although it does not cause the neurologic problems that we see in the newborn babies born to pregnant women who have Zika. Cholera keeps popping up its ugly head all over the world. There are very clear trends for how those happen. Those are transmitted by organisms that cross the oceans and get to different countries. More recently, you know, this is a chronic issue, is influenza. We always have outbreaks of influenza every year, Ebola, et cetera. So we see that we are always going to be facing new enemies and old enemies. We just need to be aware. One of the other things that happens around the spread of infectious diseases related to a local event, say a local climate event or another local event, is that we have so many people traveling around the world that if you see events in one place, they can easily be in your backyard within 10 to 12 hours. And so what are these effects? I think we've talked a little bit about this already today, but there are many, many influences, and urbanization, increased transportation. I'm so glad I bought my electric car last year. Deforestation and reforestation, land reclamation, et cetera. But the climate change issues really relate to natural disasters, extreme weather events, reduced and ineffective vector control. That's a really big problem, especially in low and middle income countries. And then reduced capacity to sustain clean water. If I get a chance, I'll try to focus on that at the end because that's critical. So when you look at this, there are not a lot of data on climate and infectious diseases, especially as it relates to kids. But I'm going to talk a little bit about the models that we teach, the epidemiologic models that we teach around this kind of trinity of what happens to us when we get infections. And that has to do, this is from a paper that I saw, really nice overview of this triangle that I always present in my lectures. And that is, it's really an interactive process between the host, that can be a human or an animal or an insect, a pathogen or an organism. It can be a virus, it can be a bacteria or amoebas, it can be anything that infects other living organisms. And then they put transmission here. I would have put here environment, but this is pretty good anyway. And so what you see here is that you can have impacts here. Human society adapts, and then you see climate change. Climate change comes about and manifests itself in this way, but all of these things really affect this whole triad. These then will change the balance of infectious diseases, and it's important to note another thing here, is that this is a bidirectional relationship, and so we can really work on this bidirectionality to make these impacts, to mitigate these impacts. And they are very nuanced and dependent on local geographical and other considerations. So these are the infections that we primarily worry about with climate change, especially in children. And I'm really only going to have a chance to talk about the vector-borne and those waterborne infections, because those are the most prominent anyway. So this is another slide from the World Health Organization. If you want data, go to the CDC website or the World Health Organization website. They have a lot of great information. But you can see, for example, and I know it's kind of tough to see, but I'll read a little bit of this. So let's just talk about environmental changes such as dams, canals, irrigation, the effect on certain diseases such as malaria and a disease called river blindness. The pathway of effect, for example, there is changing the snail host habitat and human contact, changing breeding sites for mosquitoes, which affects the prevalence of malaria, changing the ability of larvae to contact humans because the soil is moister now. Agricultural intensification can affect malaria because you have more vector resistance from insecticides, and you can argue as well that there might be more standing water, et cetera. So you see that there's a lot of changes around each impact in the environment. One that I think I'd like to bring up here is ocean warming because of the red tide and the toxic algal blooms, which have really affected the vast supplies of food, and also can affect the type of pathogens that we see in the world. So I think these are things that we're just starting to see now. Now, many of you have seen the pictures of these red blooms and what they do to the environment and to our food and to our infection rates. And so what about impacts on children? Well, as you've heard before, about 90, a vast majority of the global burden of disease overall, and there are very good studies done by a number of different groups around the world on the global burden of disease. And we've been tracking this since the mid-90s. And so we know that about 90% of the global burden really falls on children. And as you've heard before, that's a lot of the reason has to do, there are many reasons, but some of them really have to do with the way children behave and how different that is from adults. So for example, they're outside more often, and their immune systems have not been primed to see some organisms. So they're more likely to see organisms, and they may get sicker. And we know that they will get higher exposure to pathogens. Malaria is a great example where we see that most deaths and disease occur in young children. We also know that the elderly can be affected as well. So it's really the extremes in age that are affected by a lot of these infectious disease changes in the world. So I said that vector-borne and waterborne diseases were the two most important. So what are they? What are vector-borne diseases? So vector-borne diseases have to do with insects that bite and either transmit organisms through their bite or through other mechanisms of their contact with the skin. And so we call them arboviruses for arthropod-borne viruses, and these are the insects here. They require a blood-sucking component to complete the life cycle, and they are often zoonotic, which means that generally requires an animal host that then the insect will bite and then will transmit the pathogen to the human. There are at least 500 viruses in a variety of different, at least 8 viral families that can really cause arboviral disease. And this is just an example of West Nile virus, where the actual host is in birds, but we see incidental disease in large animals and humans because the mosquito, the female mosquito needs to have a blood meal. The males do not, and they need to find a host. If they can't find birds, they'll find humans. And so these are other complex cycles. This is just a general cycle looking at mosquito-borne diseases in primates, and then we get an incidental bite of a human, and then eventually that virus can adapt to humans. And then this one here is another disease, primarily, found in Rift Valley in Kenya. One of my faculty members is actually done a lot of work in understanding this particular virus and its transmission and the impact on children. So mosquitoes are other than humans, mosquitoes are the deadliest animals on the earth. They cause over 1 million deaths a year. Almost as many as humans, but not quite there. And we know, for example, in 2015, malaria alone caused almost 500,000 deaths. But in 2016, the good news, again, is when you have political will, and we almost have that number. We got down to 285 malaria deaths in 2016. So we know that we can make a difference. And I want to back up a bit and say, this is what I tell my students. Why do we talk about death so much? It sounds pretty dark and dreary, but it's the easiest way to measure immediate impact, especially when you're talking about the global situation. In the US, we have great tracking, but in most countries where I work in sub-Saharan Africa, and now we have projects in Eastern Africa as well, and the Democratic Republic of Congo, it's very hard to measure anything other than death, and even then it's very hard to estimate. So that's just the tip of the iceberg. You can imagine all the other effects that you're talking about, like was mentioned earlier. And so we do see that in high malaria transmission areas, more than 2/3 of all malaria deaths occur in children under 5. So we know that children are really affected, and we see that mosquito is the Anopheles mosquito, which we actually have in California for sure. If we had the virus, the parasite, malaria parasite, introduced into California, which actually we studied, it's happened to us before, we could have little outbreaks. What's different for us is that we're able to control the water areas, the standing water where mosquitoes can breed. But we certainly have this insect here. What's really frightening as well is that the Aedes species contribute to causing these 4 major other diseases: chikungunya, dengue, Zika, and yellow fever. We don't see very much of these in the United States, but we do have those vectors in the US. I don't have time to show you that map, but we have them in the southern US, and we're starting to see some evidence of them here, even in the Bay Area. More than half of the world's population lives in areas where these mosquitoes live. So we have a lot of opportunity if the organisms explode in population, or if they become infected with these viruses and parasites. And in the US, for example, because that's a global focus, mosquito-borne disease is the West Nile virus is the most common. And this is really interesting example of how we will see and can see spread of diseases other than we all know about Zika. But this is a disease that we did not see in the US, and actually that big hint is that the name is West Nile. So we obviously know that didn't start here in the US. But we saw it in 1999, and we saw huge epidemics, primarily on the East Coast, New York, and those areas, but now it's pretty much all over the US. And California actually has reported more cases than anywhere else in the US. And we, as I talked about the Aedes aegypti mosquito, it transmits this virus, but others as well. And so we find that mosquito in 28 states in the US. And currently more than 125 countries are considered endemic for one of the other diseases transmitted by Aedes, which is dengue. And that on first infection is not serious, but its second infection can be highly virulent and cause significant morbidity and death. So what about waterborne diseases? And these are the hidden diseases. Nobody likes to talk about. I remember Murphy Brown used to say, I don't know if any of you, well, you all remember maybe. She used to say, just say you have a gastrointestinal disease, because nobody will ask you questions. So, but it's true, and that's the sad fact, is that we don't count these very much, but we will we do count them in children because they are highly prevalent in kids. So in the US alone, we see 12 to 19 million cases of diarrheal disease, and the frequency and intensity of extreme precipitation and flooding is increasing, and these can be a factor in more than 50% of outbreaks of waterborne disease around the country and the world. And here's an interesting slide that I picked out of the San Francisco paper saying outdated FEMA flood maps don't account for climate change. And this is a town in Louisiana from last year where they were herding the cattle out to get them to safety, but this was based in what they thought was a non-flooded zone, because the maps are outdated now. And of course, as we know, down in South Carolina now, there's a lot of areas that already flood routinely. So the reason I thought this was also important is because we know that cows carry a lot of human pathogens. So if you get this into that water sitting there and you don't happen to have a good water supply, you're going to be in trouble. So what happens in that regard is that in areas with combined water sewer systems that collect sewage and stormwater runoff, you may have heavy rainfalls that can overwhelm the system. And this routinely happens in Southern California. Dick, you remember all those releases down in Santa Monica Beach. I don't think they're as frequent now, but they overwhelm the system. Municipalities may release some of this untreated waste into water bodies, especially the ocean in California, for example, to prevent any backup into homes, which would cause more problems to the individuals. But these combined sewer overflows can increase the risk of waterborne diseases, for sure. And that's assuming you have a water system in place, and that's another thing which we'll talk about in a bit. So when we look at waterborne diseases, again, I mentioned there are viruses, bacteria, amoeba, they can be lots of things. The most common ones are salmonella, and then there's a strain of salmonella that causes something called typhoid fever, which is extremely virulent and now is highly resistant to antibiotics in many parts of the world. We are actually working with a colleague at Stanford right now on efforts to track this bacteria because it's really frightening and we're worried about further resistance, so we won't be able to treat it. By the way, Stanford was founded because of typhoid fever, because the only son of Jane and Leland Stanford died of typhoid fever in Italy. And they wanted to create an institution so that all the world's children would be their children. So that's why Michelle and I and others, David, are here today. Sadly. Not sadly for us, but sadly for him. So these are very, very common. I know you all have heard of norovirus. We all know about cholera. 500,000 annual deaths occur in children due to diarrhea. And this is after the impact of a major vaccine against rotavirus, which I worked on when I was in training, which really has almost wiped out the incidence of disease from this virus in areas that can afford and can implement use of this vaccine. So we still see that diarrheal diseases are the 4th leading cause of death in children younger than 5, even now, behind preterm birth complications, newborn neurologic diseases, and lower respiratory infections. These are highest in these parts of the world. So you see the darker lines, or this is under 5 mortality from diarrheal diseases in 2015. And the good news is this number is lower than it used to be. That is, the number is lower, and the countries that are involved are smaller. I didn't have room to show you the 2005 slide, but you can see that the same areas of low and middle income countries are mostly affected. And this slide shows, I'm sorry, you don't need to see the actual numbers, but this is just a slide showing, this is a socioeconomic index here, and the higher it is, the more to the right you go, the higher the socioeconomic status. And this is the mortality rate. And what you can see here is, of course, the highest mortality occurs in areas of lower socioeconomic status, primarily because of the lack of water systems, clean water systems. So we will see that this will be an impact with increased extreme weather events, as we talked about. How do we mitigate? And I see I'm almost out of time. Well, we need better infrastructure, assuming that other people are going to be also dealing with climate change issues. What else can we do? We can increase our sustained mosquito control efforts, eliminate mosquito breeding areas. There are some genetic modification of mosquitoes, some projects that are working on that. And I know people are concerned about making sure that we don't damage the ecosystem with those. But those are some areas that are under consideration, and we need to tread cautiously when it comes to those projects. It's also that we need better diagnostics. We do need better vaccines. Again, for typhoid fever, it's a must. There are vaccines, but they're not very good, and they're a little on the expensive side. And then targeted therapeutics. And then I have just one more after this. So one other thing that one of my colleagues, Erin Mordecai, she's a biologist at Stanford, and others have looked at is taking data about climate influences now and how diseases spread in a community, and trying to use that to model and predict what will happen given changes in precipitation and temperature, et cetera. So you can see here that she was able to model the percentage of the total population that might be at risk for infection with this Ross River virus based on current temperatures. So this is just a really nice way to demonstrate that you can start to try to model risk for disease. So my last slide here is looking at WASH efforts. And WASH, for those of you who don't know, stands for water, sanitation, and hygiene. Over 500,000 people don't have access now to clean water around the world. But the good news is 91% of the world's population do have access to clean water. 1 in 3 people don't have improved sanitation. 1 in 7 practice open defecation. And we know that's a really high risk factor for many things, not just infections, but also malnutrition, stunting, and other issues. And we don't understand why that is. But since 1990, we almost over 2.5 billion people now do have access to improved sanitation. So we have come a long way. And this, again, we want to bring up this issue of health equity. So social and economic inequities really place some individuals at more risk. For example, occupation. Farm workers, other outdoor laborers, as you heard earlier, as well as children have higher risk for exposure to disease vectors. Housing conditions are important. You need to have screens to be able to keep out some of these vectors. And in many parts of the world, those are not available. Poor infrastructure in neighborhoods with aging water and water sewers. And this is a really interesting article that I read in the New York Times a few weeks ago. The city of my birth in India is becoming a climate casualty, which is a sad thing, but here she also says it didn't have to be. And she talks about the fact that the infrastructure in the city was not set up to handle the water and the climate changes that are happening even now. And this is Calcutta. And I was just there in December for my daughter's wedding, and I have to say that they have done a great job. It's a beautiful city, but there can be some very straightforward things that can be done to really mitigate some of these problems, even today. So I will stop there, and thank you for your attention.
Thank you, Bonnie. Do we have a question back there?
Thank you.
You
Hi, Juanita Constable from Natural Resources Defense Council. You talked about how in the U.S. we have pretty good monitoring and surveillance systems, but it seems that there's still a lot of data gaps when it comes to public health agencies trying to make intervention decisions. If you had one or two things on your wish list of ways we could improve that for the U.S., what would they be?
I think we need to, so we have been saying this for decades now. We need to reinforce our public health infrastructure. We just spend so little on our public health infrastructure. I don't think there's one area of public health that is well funded. I think we really need to refocus our energies on that. So if you look at what the CDC, for example, who I work with very closely, have done, they are really just our first responders in so many ways in all kinds of diseases, and we just don't, we take it for granted because when you don't see a disease, you don't think about it. So you can't prove that you didn't have a disease that you would have had if you didn't have the CDC around. So the young people say, for example, I've seen some of my kids are all millennials, and they say, one of the things they say is, oh, remember that day that you had polio? Of course you didn't, because it's not around anymore. And so I think we just forget, and that's okay, but we need to fund those people who are the first responders to keep those diseases away. So I can't really focus on one area because it's so broad.
I'm going to, there's a question here, but I want to just blow that out a little bit. We can't just think about the U.S. because of globalization. We need to strengthen IHR, the International Health Regulations of WHO. Because it's clear that we live in a globalized world. Trump may want to put blinders on that, but that infectious diseases don't work that way. Do you have a question? Yeah.
Dick Jackson, former UCLA. In my own career, I went from infectious disease to environmental health, and in part because the more you think about infectious disease, pouring your dishwater in with your black sewage from your home and then putting it in a local river is a recipe for disaster. So I have a quick question for the group and then a comment. What was the leading cause of death in California in the year 1900? And you're not allowed to speak, Bonnie. In 1900, there's a big cemetery full of these victims in Sacramento. Malaria. Malaria.
Yeah.
And so one of the big one of the things is predicted with climate change and sea level rise in the Central Valley of California that was once a giant lake. So this stuff has gone away for a while, but we're not long out of it. Now the request. With NRDC and with a bunch of other folks, we were very active about getting antibiotics out of the food, particularly going into hospitals, meat and everything else for all the reasons all of us understand. But one of the biggest things that happened was when the Infectious Disease Society came out and said, we don't want antibiotic-treated food in our hospitals. And that voice of the infectious disease community was so important. And I will tell you that 15 years ago, the infectious disease community was an opponent at CDC to attention to climate change. And I won't get into the gory stories, but it has really come around. But we need to have you wonderful experts really speaking to this, because nothing gets your attention worse than a high fever and shaking chills.
Thank you, Dick.
Thank you. Yep. Can you introduce yourself, too?
My name is Phyllis Dietz, and I have no affiliation, although I am here on behalf of our
global
Children's
citizen.
Trust. My question has to do with the melting of the permafrost. Have you any comments on how that might affect the spread of infectious diseases?
Yes. So I'm not a water expert myself, but I do know a little bit about the permafrost, primarily because that's where we were able to figure out the sequences of the flu viruses. So, but we do know that that's going to cause extensive increases in areas being flooded. We don't have the infrastructure in place around the world to be able to handle that. For example, that picture I showed you of Calcutta, when you see that, what's really happening there is you're seeing lots of urban areas that are now underwater for more periods of time during the year. And that water used to run off, but it can't anymore. So we have a permanent situation where we have to try to rebuild all of our infrastructure, especially along the coastlines. It's going to have a huge impact on transmission of diseases, because dirty water is, if you think about any natural disaster, what's the first thing that happens? Obviously, you go out to do rescue, but the other thing that the people on the ground are doing is they're making sure that there's clean water. That's the first thing that's going to kill more people than anything else.
I think also, I think Bonnie's answer is completely right, but there have been organisms that have been preserved in permafrost that have raised their head, like anthrax spores. So that's something else that's been people are looking at. That, I think you have the next question.
Hi, thanks. My name is Somini Sengupta, and thank you for that surprising shout out to my story about
Oh, there you
Calcutta.
are. Oh my God, that's super exciting. I love that article, by the way. Great job.
I was intrigued by one of the slides that said, where you said 50% of waterborne diseases are associated with extreme rainfall. And I wonder if it's possible to show how particular episodes of extreme rainfall, whether in the United States or globally, what kind of disease, what kind of diarrheal disease outbreaks they have led to, and if you can model what might happen in a hurricane category 2 or 4 or whatever.
Yeah, so I don't have the time to go into the details, but absolutely. So I was helping organize this conference at CDC called the ICE, International Conference on Emerging Infectious Diseases. It was just a few weeks ago in Atlanta. And we had a wonderful environmental engineer who actually showed a lot of that. She spent an hour showing us this wonderful data. If you want to, I can try to get you her information, because her name slips my mind now. I didn't know her before. And she talked about modeling, and it's interesting that I put that up there. I was afraid someone was going to call me out on it, because in fact, there is also evidence that periods of drought can be associated with disease. So it's both. So you get a double whammy, and the drought there's a lot of reasons for that that people don't really understand yet, but and people are looking at specific pathogens. They're not tracking overall water changes and then all pathogens. But there are a number of data, but the most common ones would be things like salmonella, for example, cryptosporidium, E. coli. Anything that comes from a cow's rear end will be in the water for sure, and some of the parasites as well.
I think we have to, I know you have a question, but we're going to have people come up a little bit later. But also just a quickie is that we're seeing now huge valley fever, coccidioidomycosis, drought versus rainfall. It's been very well shown that. But I'm going to ask Bonnie, thank you very much.